Hello everyone, we are Team Fossil. Today we will present our project titled From Occupied to Actually Used. Our project aims to transform seats that are only marked as occupied into seats that are actually being used. Our presentation will proceed in the following order. First, we will explain motivation, then analyze the current system and its problems, and finally present our solution, expected impact, and budget. First, let me explain the motivation of our project. Currently, library use a QR code-based seat management system. However, this system has a limitation because it depends on user action. In other words, if user don't properly scan the QR code, there is a mismatch between the actual seat usage and the system status. In addition, even though library enforces strict seat usage rules, the problem of seat monopolization still occurs. This means that individuals occupy seats for long periods even when they are not actually using them. This clearly shows the limitation of the current system. Looking at the current situation, if a user leaves the seat without scanning the QR code, the system still shows the seat as occupied. As a result, seats that are actually empty remain unavailable to others, which lead to seat monopolization. Now let's look at the existing technology. Currently, library use QR-based seat management system. This system assigns seats and tracks occupancy through QR code scanning. Users scan the QR code when they sit down and scan it again when they sit lead to update the seat status. In other words, the seat status is entirely dependent on user input. However, this system has a critical limitation. It cannot detect whether a person is actually present. For example, if a user leaves without scanning the QR code, the seat remains marked as occupied even though it is actually empty. Therefore, QR-based system cannot accurately determine real seat usage. Next, I will explain the FSR sensor. FSR sensor stands for Force Sensing Register. This sensor change its resistance depending on the applied pressure. When an object is placed on the seat, pressure is applied to the sensor, and this change is converted into an electrical signal. By attaching this sensor to the seat, we can detect whether there is an object on the seat. Next is PIR sensor. PIR stands for Passive Infrared Sensor. This sensor detects infrared radiation emitted from the human body. When a person moves, the infrared pattern changes, and the sensor detects this change as an electrical signal. Therefore, the PIR sensor can determine whether a person is actively present at the seat. The FSR sensor can detect the presence of the object, but it cannot tell if if it is a person of just belongings. On on the other hand, the PIR sensor detects human motion, but it cannot detect anything when there is no movement. So by combining both sensors, we can more accurately determine actual seat, excessive, usage. To summarize, the current system has several problems. There is a mismatch between actual usage and system status. Seats remain occupied when QR code are not updated. This reduces seat efficiency and it leads to seat monopolization. As a result, the library space is not used efficiently. To solve these problems, we propose a sensor-based seat management system. By using both FSR and PIR sensor, we can determine the actual seat usage. If no movement is detected for a certain period, an LED will indicate that the seat is vacant. Our goal is eliminate ghost seat, which are seats occupied only by belongings. Our system works by combining FSR and PIR sensor. First, the FSR sensor detects pressure on the seat. This allows us to determine whether an object is present. Next, PIR sensor detects human motion through infrared change by combining these two signals. We can accurately classify seat condition. For example, if both FSR and PIR are detected, the seat is actively in use. If FSR is detected but PIR is not detected for a certain time, the seat is considered unattended. If FSR is not detected, the seat is empty. In this way, our system does not vary on user input, but automatically determines seat usage. Additionally, seats without activity are indicated by LED, allowing easy identification. With this system, we expect the following benefits: reduction of ghost seat and improved seat availability, peak identification using LED indicators, reduce manual workload for management, and practical implementation due to low cost. This system will be especially effective during peak periods such as exam season. The bucket is as follows. The system consists of Arduino sensors and base components, and the total cost is approximately 43,318 won, which make it cost effective. Thank you for your attention.